Hi guys, Miss O'Connell here. So today we're going to be talking about elastic collisions, which, if you remember from class Monday or yesterday, those are collisions in which objects typically bounce after the collision. So in this quick video, what we're going to do is take a look at some fully elastic collisions. Okay, in nature, we don't see these types of collisions as much as we would see an inelastic collision. But this video is going to take a look at some examples as close to a fully elastic collision as we could see. So let's take a look. Notice how they're using a exercise ball to aid in the elastic collision. The first two were, people of relatively the same mass. Let's see what happens in the collision. Okay, now we have two exercise balls. Both objects have initial velocity. Okay, now we have four objects colliding. Momentum is always conserved in collisions. Okay, so the last clip here is looking at collisions at angles, right? These balls are colliding at an angle. The beginning of the video focused on head-on collisions, or collisions in which one object was moving and the other object was stationary. From the clip, can we recognize any patterns that we might have seen in lab? So what did we observe in the clip about the elastic collisions? Okay, so hopefully we noticed, right, when objects of the same mass collide, the velocity is transferred. Okay, so when two objects of the same mass collide, the velocity is transferred. When two objects of different masses collide and both have an initial velocity, we can see that the lighter object gains more velocity. Okay, it gains more momentum. Momentum is transferred in the collision. So the lighter object will bounce or repel quicker, faster, with a larger velocity after the elastic collision. Okay, so we're going to take a second and jot those down, add that to our guided notes. So some additional principles of elastic collisions, besides the fact that they just bounce in the collision, when objects of the same mass collide, they physically switch velocities. When a bigger object hits a smaller object, the bigger object tends to either continue in the same direction, while the small object is going to rebound with a faster speed or a faster velocity. momentum is transferred in the collision. Okay, as we noted yesterday in class, on the front page of our guided notes, we know that momentum is always conserved in elastic and perfectly inelastic collisions. So we know that the momentum of the system before the collision must be equal to the momentum of the system after the collision. So let's take a look at a few examples, starting with example 26. Okay, so in example 26, we have a particle, a red particle here, with a mass of 4 kilograms. So M1, object 1, is 4 kilograms. It's initially moving with a velocity of 2 meters per second east. We know that east is a positive direction. The velocity of object 1 initially, so V1 initial, is 2, a positive 2 meters per second. That particle collides elastically, so that word elastically tells us it's an elastic collision, with a particle of mass, we're going to call it M2, 6 kilograms, that is initially moving with a velocity of 4 meters per second west. So that means that V2 initial is negative 4 meters per second. If the velocity after the collision, okay, so that gave us our before picture, our information about both objects in the system before they collide. Now we're getting information about after the collision. So we're going to make our after diagram, or our after sketch. We have both a red particle and a blue particle. And let's talk about what happens after they collide. Okay, so if the velocity after the collision for the 4 kilogram particle is 5.2 meters per second west, so west means the negative direction, that means that V1 final is going to be negative 5.2. meters per second. We're asked to find the velocity of the 6 kilogram particle after the collision. So we ask you this. Make a prediction. So after the collision, which direction do you think the blue particle is going to move if the red and blue particle collide elastically? Okay, so hopefully we noticed that M2 and V2 initial, right, the momentum of the object 2 initially is larger than the momentum of the object, which we called 1, the red particle, initially. So if the blue particle has more momentum, it's most likely going to continue to move in that direction after the collision. Okay, but we know that the lighter object, the 4 kilogram object, is going to have a larger velocity. So you find the velocity, it should be smaller than 5.2, and it should be to the left. Okay, so let's give it a shot. Let's calculate exactly what the final velocity of the blue particle will be after the collision. So we know that in all collisions, momentum is conserved, so we can use law of conservation of momentum to solve this problem. So P initial equals P final. I'm going to write out our equation for collisions. M1 V1 initial plus mass 2 times the initial velocity of object 2 will be equal to the mass of object 1 times its final velocity plus the mass of object 2 times its final velocity, which we are looking for. Okay, now we plug in Rest will be algebra from here. So M1 we know is 4 kilograms. We're going to multiply that by the initial velocity, which is 2 meters per second. We're going to add that to the momentum of object 2 initially, which will be the product of 6 kilograms times negative 4 meters per second. That's going to equal to mass 1, which is again 4, and the final velocity of object 1, which the problem told us is negative 5.2 meters per second. And then we're going to add that again to the final velocity of object 2, the blue particle, which has a mass of 6, and we don't know the final velocity, VT final. So we leave that as a variable. Okay, so I should really have the units in here. When we simplify 4 times 2, we get 8 kilogram meters over seconds minus 24 kilogram meters per second is equal to negative 20.8 kilogram meters per second plus 6 kilograms times V2 final. So we know that these all have the same units. They're connected by either addition or subtraction, so we can simplify. So when I have 8 minus 24, I'll get negative 16 kilogram meters per second. And then I'm going to have negative 16. I need to add 20.8 to both sides of the equation. So negative 16 plus 20.8, we get 4.8. Kilogram meters per second is equal to, the rest of the equation will stay the same, 6 kilograms times V2 final. So you get a positive value when we take 8 minus 24 and then we add 20.8. So what that means is that the final velocity is actually going to be positive. So the objects will rebound in opposite directions, but the velocity of this object is going to be very, very small in the opposite direction. Okay, so it's going to rebound, but only slightly. Our last step, divide both sides of the equation by 6 kilograms to get V2 final by itself. Our kilograms will cancel, and we're left with 0.8 meters per second. So the blue object, the one that has initially more momentum, is going to rebound with a velocity of 0.8 meters per second. Okay, so you have two objects of differing masses here. Usually what happens is that either the object with the largest mass continues to move forward a little bit, or sometimes it rebounds. Okay, in this case, mass difference isn't that large, so the blue object, the blue particle, is going to rebound at a smaller velocity than the smaller particle. Right? The smaller particle will gain more velocity after the collision due to the transfer of momentum. Okay, so 0.8 is less than 5.2, so we're good. Okay, so this last question is a little bit more of a conceptual question. So it is open-ended, it's on a multiple choice, but it's asking you about the concepts. So in this image here, we have two blocks that are a frictionless surface, and they have the same mass, m. So they have the same mass. You have two objects of the same mass colliding. Block 2 is initially at rest, and block 1 moves to the left with a speed of 4v. It's going to collide elastically with block 2. What are the final speeds of block 1 and 4? That should really say 2. That's a typo. Please change that in your notes as well. So what are the final speeds of block 1 and 4? So block 1 is initially moving with a velocity of 4 times v. Block 2 has an initial velocity of 0. Okay, so V2 initial is 0, V1 initial is 4V. So you have two objects of the same mass colliding elastically. So you take a minute and think through this problem.